Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan Zakiri Marzali, DE220210. Uh, Today I would like to give the introduction for our assignment. Uh, the assignment given the choice about tuning control system technique for excellence. That we have two choices of method. The choices between the Ziegler Nichols method and PID tuner. For tuning control depends on various factors, including the complexity of the system, desired control performance, and available to tools in order to tune the control system. The approaching two methods are Ziegler Nichols method and PID tuner being discussed within the analysis, since another objective is to find the best approaching between the method by discussing the options results, so the method can be applied with ease for a wide range of use. Most of discussion tuning rules can be found where PI, and also PID tuning rules are given for various process models, including the discussion here. The Ziegler-Nichols method. The step response, frequency response method are classified tuning method for PID controller. The first question is about open loop system, and the second questions that they ask us to do for closed loop system. So this is the table. So these they are determined by drawing target line inflection point where slope of the step response has the maximum value peak. So uh, the top one, as the table show that 1.2 value is at top, then we can find the rest time for this intersection for tangent and coordinate axis given process parameters shown in figures 1. These are used to calculating the control parameter KP, TI, and TD. So there are a lot of methods being used here to calculating the P and PI and also PID. And maybe this will be my final explanations for this project. So I will pass to explain for question 1 open loop and question 2 for closed loop. So thank you and assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum, we are Group 7, tasked in designing and simulating a PID controller circuit for a closed-loop system. In definition, a controller is a comparative device that receives an input signal from a measured process variable, compares this value with that of a predetermined control point value or set point, and determines the appropriate amount of output signal required by the final control element to provide corrective action within a control loop. PID controller uses three basic behavior types of modes. Firstly, proportional controller. A P controller system is a type of linear feedback control system. The P controller system is more complex than on-off control system like a bimetallic domestic thermostat, but simpler than a PID control system used in something like an automobile cruise control in general. It can be said that P controllers cannot stabilize higher order processes. Below is a block diagram of a P controller. Secondly, proportional integral controller. The PI controller is most widely adopted in industrial application due to its simple structure, easy to design, and low cost. PI controller will eliminate forced oscillation and steady-state error resulting in operation of on-off controller and P controller respectively. However, introducing integral mode has a negative effect on the speed of the response and overall stability of the system. Below is a block diagram of a PI controller. Thirdly, proportional integral derivative controller. PID controller is most commonly used algorithm for controller design and is most widely used in controller in industry. The PID controller algorithm utilized for its design velocity algorithm. It is also called incremental algorithm. PID controller has all the necessary dynamics, fast reaction on change of the controller input, increase in controller signal to lead error towards zero, and suitable action inside control area to eliminate oscillations. Below is a block diagram of a PID controller. Moving on to methodology, we'll be using MATLAB, which is a programming platform designed specifically for engineers and scientists to analyze and design systems and products that transforms our world. When creating the circuit, we use two different types of tuning to get different results, which are the Ziegler-Nichols method. This method starts by zeroing the integral and differential gains and then raising the proportional gain until the system is unstable. The value of Kp at the point of instability is called Kmax. The frequency of oscillation is F naught. The method then backs up the proportional gain and predetermined amounts and set the integral and differential gains as a function of F naught. The P, I, and D gains are set according to figure 3. Next is the PID tuning method. PID tuning is the process of finding the values of proportional, integral, and derivative gains of a PID controller to achieve desired performance and meet design requirements. The PID tuner app automatically tunes the gains of a PID controller for a CISO plan to achieve a balance between performance and robustness. We can specify the controller type such as PI, PID with derivative filter, or 2 degree of freedom, 2DOF, PID controllers.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Abra bin Makhir and my matrix number is DE220153. So the assignment required to do the open loop system and also the closed loop system by using our selected transfer function, and also the requirement for the transfer function is second order and third order transfer function. Okay, so also we need to get our transient response by using the PID controller, by using the two approaching method, which is the Ziegler Nichols method and PID tuner Simulink. Okay, so let's start our simulation. So here we create our open loop system first. So for our transfer function, we use the third order transfer function. So we can get our transient response by simply run it. And so here we can use our gain first. So this gain is to get our critical period, which is very important to determine our all the gains value. So you can try add the number a little bit higher. What about the 7.5? Yes. By find our peak to peak. So peak to peak here, we can get the critical period. And so from here we can use this calculation to get the gain, all the gain that we need to find. And let's do some cheat. I don't know, maybe it can help a little bit. So this is let's define this as a P only, 4.5. All right, and this is for the PI 4.557, and this is for the PID. So let's run. So now we get our PID. Let's arrange. Okay, so this is for the P, and this is for PI, and this is for PID. And this is also from the Ziegler-Nichols method to derive our transient response. So let's move to the second method, which is use the PID tuner. So here we get the P controller by using the PID tuner Simulink. So this is the value for the gain of P that suggests by the PID tuner Simulink. So, and this is the graph. And you can use the same step to derive our PI and PID controller. And here the suggested, and let's apply to save the change, and okay. And so next for the PID, same transient response for PID controller by using all the gain PID, and apply the change, and okay. So we can run. The transient response will appear that this is the suggestion that suggests by the PID tuner Simulink. So that's all from me. Thank you for watching.
Assalamualaikum. My name is Ahmad Kifayatullah bin Kamis, nama metrik DE220083. I want to present about discussion. So for open loop system, the output graph behavior indicate a significant issue with system instability since it shows a graph that is continuously growing without stopping. Verifying the system poles which are established by the denominator polynomial root is important. If the real part of this pole is positive, it is obviously demonstrate how unstable the system is. Next, for closed loop system, Ziegler-Nichols methods. Its primary objective is to establish appropriate values for the proportional, integral, and derivative gains of the PID controller. The procedure commences by setting the integral and derivative gains to 0 and gradually increasing the proportional gain until the system displays sustained oscillation. Next, for closed loop system, PID auto-tuner. For closed loop system, PID auto-tuner, all the controller P, PI, and PID already tuned and get the value for proportional gain, integral gain, derivative gain, and filter coefficient. Next, we also take the data for rise time, settling time, and overshoot. But controller P integral gain, derivative gain, and filter coefficient not applicable, while controller PI integral gain were applied. Lastly, for conclusion, in summary, the Ziegler-Nichols method and PID auto-tuner both aim to optimize PID controllers, but they differ significantly in their approach. The Ziegler-Nichols method relies on manual adjustment and oscillation observation, while PID auto-tuner utilizes automated adjustment and real-time data feedback. Manual calculation based on Ziegler method can determine specific values for proportional gain, integral time, and derivative time. Additionally, the method offers a structured framework for manual PID controller fine-tuning, facilitating satisfactory control without extensive calculation, particularly beneficial for students. I think that's all from me. Thank you.